when an object is placed in a gravitational field, that object is attracted. Means the object feels a force of attraction toward the center of the massive object, due to which the gravitational field exists. This thing we get, means this concept we get from Newton's law of gravitation. You know that according to Newton's law of gravitation, the force of gravitation, means gravitational force of attraction, is proportional to the product of their masses, means product of the two bodies, two objects, and inversely proportional to the square of the distance between them. So if masses are more, force of attraction is more. If distance is more, force of attraction is less, because it is inversely proportional. So here from this formula, means from the formula of Newton's law of gravitation, we are getting force. But in case of orbital mechanics, such as satellites, artificial satellites revolving around the Earth, or the motion of moon means you know that the moon also rotates around the Earth. So in such cases, analyzing the motions of moons, that is natural satellite, again artificial satellites are there. So in those cases, instead of using the concept of force, if you use the concept of potential energy, means gravitational potential energy, then the calculations become easier. And that's why the concept of potential energy is used, means gravitational potential energy. There are so many types of potential energies, you know. So gravitational potential energy, actually the absolute value of gravitational potential energy is not calculated in any of the calculations. The difference between the gravitational potential energies at 2 points, that is required for the calculation, and that is calculated. Okay, you know that if we consider our planet Earth as the massive object, then for any other object, what is the force of gravitation? It is just equal to the weight of the object. So if m be the mass of the object, small g is the g be the acceleration due to gravity, then small m multiplied by small g, that is the weight of the object, and that is the force of attraction on the small object by the planet Earth. For any other planets, same thing happens. Okay. So, and how potential energy is calculated? Whenever you are, say an object is there of mass m, okay, and if you move that object from a point to another point, and if you are moving away from the center of the Earth, then in that case you need to do work upon the object. Means you are taking the object against gravity, against gravitational pull. You are taking the object. Whenever you are taking the object away from the center of the Earth, in that case you have to supply work done, means you have to supply energy to that object, means your work is done on the object, and that work done is stored in the object as potential energy. That energy can be utilized to do some useful work. That energy can be utilized to get motion, you know, conversion of potential energy into kinetic energy. Okay, anyway, I was discussing about calculation of potential energy, means gravitational potential energy. So, weight of the object is mg, and when you are making a displacement of amount h, small h, okay, then what is the work done? It is equal to force multiplied by the displacement. So force is how much? It is mg, displacement is h, therefore mg into small h is equal to work done on that small object. So this mgh, this is the potential energy of the object. Where was the initial point from where the displacement was measured? That choice is arbitrary. Anywhere you can choose that point. Okay. Normally, in most of the calculations, the surface of the earth is taken as the reference point. Means any line which is parallel to the surface of the earth, on that line if you take any point, that point is chosen as the reference point for the calculation of potential energy. But this is not fixed, this rule is not fixed. Anywhere of your own choice, you can take the reference point. Yes, one thing is there which you have to notice carefully. After choosing the reference point, if you are moving that small object away from the center of the earth, then in that case potential energy gained will be positive. And with reference to that point, even moving toward the center of the earth, in that case potential energy will be negative. So somewhere here, you just consider this point. Here there is one object, okay? And if you move away the object somewhere here, then there is gain in potential energy with respect to this reference point. Okay? And say you are moving the object somewhere here, beneath this position, okay? In that case, potential energy gained with respect to this point will be negative. So, reference point is your choice, but in most of the cases, surface of the earth is taken as the reference point. One more thing I should mention here, that is the force which is being considered here is small m into small g. Small g is acceleration due to gravity, the value of which is 9.8 meter per second square near the earth's surface, on the earth's surface and near the earth's surface. But you know that radius of the earth is almost it is around 6,400 kilometers. And here small h is being used as the distance or the displacement. If this small h is very less than as compared to the radius of the earth, in that case the force mg remains constant because small g remains constant. Due to little variation in h, there is almost no variation in the force of attraction, and due to which small g remains almost fixed, constant. But if you move too much away from the center of the earth, such as the height of the satellites, artificial satellites, the distance of the earth, in those cases you have to consider the variation in small g also. Okay, in those cases force is not constant and small g is not equal to 9.8 meter per second square. So whenever there is a change in small g, or whenever there is a drastic change from the center of the earth during the motion, okay, in those cases you have to take into account the effect of variable force, and accordingly you have to calculate the potential energy. But in the gravitational field, where there is almost no change from the center of the earth, or change is very small, almost no change means change is very small, in all those cases you can consider the force to be constant, and in all those cases you can consider the potential energy to be mg multiplied by the distance h. So that is the gravitational potential energy. Okay, and that energy can be used to do any work. Anyway, such things I am not going to discuss here in this video. Here in this video, my aim was to discuss about how to calculate gravitational potential energy in a gravitational field where the force is constant. And the concept of potential energy can be used only in case of conservative forces. You know, you have idea about conservative forces. If in a round trip, if the work done becomes zero, total work done becomes zero, means say you are moving an object from one initial point to a final point along a curved path, and if the initial position and the final position becomes same, okay, and if your work done, total work done becomes zero, in that case the force field is considered to be conservative in nature. So gravitational field, in this case, force field is conservative. Of course, when you are neglecting the effect of air, because any object is surrounded by air, okay, when you are neglecting the effect of air, means force which is being considered only due to the gravitational pull of the earth, in that case the force field is conservative. In case of spring mass system, there also force field is conservative, but in case of frictional forces, whenever there is friction present and you are considering the effect of friction also, in case of frictional forces, force field is not conservative. So in those cases, the total work done will not be zero. So whenever there is a conservative force field, the concept of potential energy can be used, and the use of potential energy makes the calculations easier. Anyway, this was all about the concept of gravitational potential energy. Okay, thank you for watching this video.